We're ready to begin Lesson 13 worksheet on subatomic heavyweights. And really, those are the isotopes of the elements we've been looking at. And so the definition of an isotope is atoms of the same element that have different number of neutrons. So that's something to keep in mind as we go through this, and I'll remind you as we go on. So the purpose is to investigate isotopes and average atomic mass. So part 1, the average boron atom. So we have a drawing of 10 boron atoms, and what they are asking you to think about is if we had a big stack of boron, a whole bunch of atoms, and we pulled 10 of them out, these 10 would be representative of a sample of boron. And so what we're going to see is how are they alike and how are they different. So with the little chart that we have down here, we're going to fill in our information. And so when we first look at the chart, they're asking you to put number of protons in. And just to let you know, if you want to make yourself a little note over to the side here, that the white dots are protons and the dark dots are neutrons. So when we start counting, we can see that they have 5 protons. And you don't really need to count all of them. If they're telling you that all of them are boron atoms, then we're going to have 5 protons in the boron atoms. The next thing they ask you is to look for number of neutrons. And so you can see in atom number 1, there's 5 neutrons. In atom number 2, 5 neutrons. And atom number 3, 1, 2, 3, 4, 5, and 6. So there's 6 in 3, and as you go on you can see that there's 6 in all the others. And then number of electrons, these are all neutral atoms. So in neutral atoms, the number of electrons will always equal the number of protons. So if we've got 5 protons, we're going to have 5 electrons. So for each of the questions we go through, I'm going to ask you to pause, hit the pause for the video so that you have time to fill in the blanks. So you're going to fill in the rest of the blanks on this, so go ahead and hit pause now. Okay, you should be back for question number 2. How many different isotopes of boron are shown? So again, the definition of an isotope is atoms of the same element with different numbers of neutrons. So when you look back at your chart, you're going to see that the number of neutrons in atom 1 and 2 is 5, and the rest of the atoms had 6 neutrons. And so we've got 2 atoms of one kind of isotope and 8 atoms of another kind of isotope. So we've got 2 different kinds of isotopes. So you should have a 2 here. Then it says how many of each type of isotope are present in the sample of 10 atoms. What is the atomic mass of each isotope? So you can easily see when you look at the chart, you have 2 isotopes that have 5 neutrons. Or, I'm sorry, 2 atoms that have 5 neutrons and 8 atoms that have 6 neutrons. So we have 2 of each type, or 2 of one type and 8 of the other. And then it says, what's the atomic mass of each isotope? Remember that atomic mass is calculated by adding number of protons to number of neutrons. So take a minute and answer that question. Hit pause. Okay, you should be back for question number 4. What is the average atomic mass of the 10 atoms? How does this answer compare to the average atomic mass of boron listed on the periodic table? So remember, to find an average, you add the atomic mass of all 10 atoms together and then divide by 10. And that number should be very, very close, or if not identical, to boron's average atomic mass on the periodic table. So hit pause now and fill in that question. Number 5. Imagine that you could examine a randomly chosen sample of 100 boron atoms. What isotopes would you expect to find? How many of each? Express your answers as percent. So let's picture that pile of boron atoms. We're going to pull out 100 of them. You would expect that 100 would be very representative of the 10 you pulled out. So you expect to see pretty much the same thing. So what kind of isotopes would you expect to find? I would think that they would be very much like you found in the 10. How many of each? So think about the ratio of 2 to 8 in a sample of 10. So in a sample of 100, you would expect to find 20 to 80. So then, 20 atoms of the boron that has 5 neutrons and 80 atoms of the boron that has 6 neutrons. So now you need to go through and express those answers as percents. Hit pause. Part 2, the number of neutrons. We're going to complete the table. This table is one that you have done before. Each time they give you a little bit less or a little different thing to look for. The symbols are the same as we did before. The atomic number is the same as before. Atomic mass. Remember, it says average atomic mass, so it's going to be a decimal point number. Number of protons, you find that on the periodic table. Number of electrons, we are dealing with neutral atoms. So what happens when you have a neutral atom? How do you figure out number of electrons? Possible number of neutrons. This is different. So I want you to think about this for a second. The atomic number of boron, if you look at your periodic table, the atomic number is 5. Oops, sorry. And then the average atomic mass of boron is 10.81. Okay, the number of protons in boron is always going to be the same as the atomic number is 5. The number of electrons, it's a neutral atom, so if I have 5 positives, I'm going to have 5 negatives. So what you'll have to wonder now is, how did they come up with this number? This number is taking this and rounding it to 11, and then you do 11 minus 5, and 11 minus 5 gives us the 6. Okay, so we know that we have some types of boron that have 6 neutrons. So how did they get this 5? Well, look at this number. It's less than 11. And if the average atomic mass of boron is close to 11, then that means there's more atoms with 6 neutrons in them, but they all don't have 6 neutrons in them, or this number would be 11 flat. Because it's less than 11 and it's an average, that means there must be some out there with 5. If there weren't any out there with 5 and there were some out there with 7, then you would expect this number to be greater than 11. Okay, so kind of think about when you're averaging out. If we're rounding this to 11 and we do 11 minus 5, we're going to get 6. So we know we're going to have that for sure. But because this number is less than 11, it's quite possible that we have some out there that would have 5 neutrons and 5 protons, and in that case we would have an atomic mass of 10. So we've got some averaging that will happen here. So as you go through here, these numbers you should be able to figure out. These under neutrons, you're going to be making a guess. Okay, pause and go ahead and fill that out. Question 2. How many isotopes does argon have? So you're going to look on the periodic table and find argon. Argon happens to be element 18. And we can see that it has an average atomic mass of 39.95. Okay, and so because it has that atomic mass of 39.95, we know that for sure that the most abundant form of argon is going to have a mass of 40, where 18 will be your protons and 22 will be your neutrons. But because this is less than 40, then we probably have some with less neutrons. Okay, so think this out. If this is your average, and you take this and round it to 40 and subtract your 18 protons, you're going to get 22 neutrons. And so we know we have one with a mass that's very close to 40. But since it's under 40, we could also have some with less than 22 neutrons, like 21 or 20. Okay, so which isotope of, I'm going to get rid of this for you here so you don't get confused. Go ahead and hit pause and finish number 2. For number 3, number 3 says which isotope of argon must be most common, and you need to explain your reasoning. So think about what I set up here about how we find those averages, and then that answer will go here. So then pause your computer and answer number 3. Number 4. If you somehow manage to isolate a single atom of lithium, how many neutrons would it probably have in its nucleus? Explain. So you find lithium and it has 6.94 is the average. That means the most abundant form is going to have a mass of 7. So we'll end up having a mass of 7. And if that's the case, let me type this in for you. If the mass is 7, then you're going to take the 7 and you'll subtract the 3 protons, and that means you're going to have 4 neutrons. Okay, so remember, you're always looking for the most abundant form to help you do your calculations. Okay, so take a minute, pause, and answer that explanation. Number 5. Explain why the average atomic mass of the elements listed in the periodic table are usually not whole numbers. And so the clue to this one is to go back and look at the 10 atoms that you had in our sample of boron. When you take all 10, they all had just rounded numbers for their mass. There was no decimal points there. But when you took all 10 and added them together and divided by 10, you then ended up with a decimal point. So think about how that can help you answer this question. Go ahead and hit pause and answer the question. Number 6. Looking at number 6, I helped you out by writing an equation on the bottom of the page for you. So you might want to be looking at that while I explain this one. So it says the element copper, Cu, has 2 naturally occurring isotopes. 69.2% of all the copper samples consist of atoms with 34 neutrons, and 30.8% of all the samples consist of atoms with 36 neutrons. Calculate the average atomic mass of copper atoms. We will eventually be doing lots of these problems, but I'm going to show you what a basic equation for that looks like, and I've kind of set it up for you to make life easy. So if you look over where I wrote mass over here on your paper that has been handed out to you, I have Cu with a mass of 63 and Cu with a mass of 65. And remember, copper will always have 29 protons. So that means that copper 65 has 2 more neutrons than copper 63. So if you look at the equation I wrote you, I took the 69.2% and multiplied it times copper 63's mass plus 30.8% of it is copper 65. And so to find out the average atomic mass, I put it over 100 because 100% of it would be all of the copper that's out there. And so when you go to do your calculations, you'll do 69.2 times 63 plus 30.8 times 65 equals, then hit your equal sign, and then divide it by 100, and that will give you your average atomic mass of the copper atom. So make sure that on your paper you write that all in here. Don't panic yet if you don't understand that equation. We will actually sit and do many problems with that on there, so you can have help with that. Okay, make sure that you put your name on your paper and turn that in by the end of the period.